For this lesson, we're going to look at something different than the graphs we've been looking at. Instead, we're going to look at lists of numbers and how to describe them. These are called sequences. So our objective is to understand arithmetic sequences and series. So first of all, let's define some of the terms. A sequence is just a list of numbers. So any list of numbers we give is going to be a sequence. Notice that you've got numbers with commas between them. That gives us a sequence. Later we'll talk about series, and the series will replace these commas with plus signs because you're going to add the sequence together. But for now, let's talk about the sequence. An arithmetic sequence is a sequence where to get to the next term, you always add the same number on each time. Let's use this as an example. Notice to get from 5 to 16, we add 11. To get from 16 to 27, we add 11. To get from 27 to 38, you add 11. That's the pattern of adding the same number. Okay, so an arithmetic sequence is the pattern of adding the same number to get to the next term. So that's what our topic is for this, is arithmetic sequences. So notice that add is the key word here to get to the next term. All right, so if you look at this, we're also going to add on some notation. So we might use any letter like to define the sequence, but we're going to call these each with the letter A with a subscript. This is saying that this is the first term in the sequence. The subscript is instead of a superscript that goes up above, the subscript goes down below to describe what number in the sequence we're at. So this would be A sub 2, this would be A sub 3, and this would be A sub 4, etc. And then we'll go on from there. Let's say that I wanted you to figure out what it is that the next term would be. That would be A sub 5. A sub 5 is we take A sub 4 and we add 11 each time onto it. And so that would give us, the previous term was 38, add 11, and you get a 49. That's the pattern we follow with these. The way we define a sequence is we have to determine, for an arithmetic sequence, we have to say what is the first term listed and what are we going to add each time we get to the next term. So we usually define a sequence, arithmetic sequences, the first term is 5, and then D, which means the common difference, that common difference here is equal to 11. So we'll use those two letters, and what number sequence we're in the sequence, in this case the first term, and then D for the common difference. Let's look at this sequence and see if we can define it the same way. Notice that to get to the next term, we're adding a -5. It's okay to add negatives. It's like subtraction, but we're going to talk about it as adding a negative. Add -5, add -5, add -5. So how we define this sequence is we say that the first term is 12, and the common difference is equal to -5 for what we're adding each time. So if I said notice this is the first term, second term, third term, fourth term, fifth term, A sub 5. If I asked you for what is A sub 6 on this one, you would say, all right, let's take that -8. Let's add a -5 to it. The previous term, add -5, and you would get -13 to get to the next term. Now notice this is very helpful for us to be able to find next terms and find that pattern as we do it. So that's called a recursive formula. Recursive means that you're going to work with what comes previously to get what comes next. So, use what came before to get what comes next. Right, so here we use the previous term, -8, to get to the next term, -13. So this is where the new notation is going to sink in. You're going to have a lot of new notation in this lesson, and we're going to use this idea of using the first term and what comes next to define each of these sequences. So the notation will look different. You got to get used to it, but this is the kind of the crux of what we're going to work with. So a sub n, this is the recursive formula format. A sub n is going to equal, and we put a brace here to represent that there's going to be two lines to it. We have to define what the first term is for n equal to 1, and then we have to define what the next term is. Now, so this one, let's put first term. And then we're going to, this is where it's a little unusual. You got to get used to this. If this is the term I'm trying to get, I want to use the previous term to get it. So this a sub n minus 1 is the previous term. And I'm going to add the common difference to each time to get to the next term. Now, that's for n greater than 1. So this just means that for the first, for that n equal to 1, we're going to have the first term. So look at this, what it means. Okay, so notice I defined the first term for this. First term was 12, and then I said, okay, we're going to add -5 on. The previous term to a sub 6 was a sub 5. You add -5 onto it, and you get that, that answer of what a sub 6 is equal to. All right, so looking at these examples here, let's go ahead and do these two. Okay, so example 1 up here, how I write it in this recursive formula. Now watch this pattern, because really there's only two things that change in this formula, the a sub 1 and the d. Everything else looks the same. So what I'm going to have is a sub n equals, and I'm going to have a blank here for n equal to 1, and I'm going to have a sub n minus 1 plus a blank d for n greater than 1. Every time you write a recursive formula for an arithmetic sequence, you're going to write it out this way, and what you'll do then is you'll put into the blank these numbers. The first term is 12. I'm sorry, for example 1, go back to example 1 here. That's example 2. Example 1 here, the first term is 5, and the common difference was 11 each time. So all you have to do is fill in those two blanks. Let's do the same thing with the second example here. It's going to look very much the same. A sub n equals, and you're going to have a blank spot for n equal to 1. And you're going to have the a sub n minus 1, the previous term, plus some common difference for n greater than 1. Let's go to the problem itself and pick those out. The first term is 12. And the common difference then is -5 each time. We add that on each time. So that's the format of how we write this explicit formula. Excuse me, this recursive formula. Now, this is nice when you want to get to terms close by what you have. Like if we asked for the 7th term or the 8th term, we could just add on, for this one, -5 to get to that term, or this one, 11 to get to that term. But what if I wanted to get to the 100th term or the 1000th term? Adding on that number each time to get out to it would be very cumbersome. So instead, what we want to do is come up with what's called an explicit formula, which allows you to jump to the number that you want. Allows you to jump to a term further in the sequence. Now this also follows a pattern, but what's nice about the explicit format is the explicit form has only one line to it. This has always two lines to it. You have to have the first term and what you add each time. The explicit formula looks like this. You're going to take a sub n, define what the first term is, and then add, here's where you need a little explanation for it, n minus 1 times d. Now, why is it n minus 1? Well, think about some of these sequences that we have up here. If you look up here, to get to this term out here, to get to the 38, which is the 1, 2, 3, 4th term in the sequence, I take 5 and I add 11 3 times, one less than the number term we're at. We're at the 4th term, but we added 11 only 3 times. Why only 3 times? Because you didn't add 11 to get to the first term. You started with it, and to get to the second term, you added 11. To get to the third term, you added 11 twice. To get to the 4th term, you added 11 3 times. Same thing here, to get out to the 1, 2, 3, 4, 5th term, I add negative 5, 1, 2, 3, 4 times, one less than it. So this n minus 1 represents that you're always working with one less than what it was that the number term that you're looking for. All right, so just remember this is your first term. This is always just one less than n. And this is still your common difference. All right, so for example 1 up here, again, I'm going to write it out, a sub n equals, and there's going to be 2 blanks, the first term plus n minus 1 times the common difference. So for this, we're going to put into those blanks my 2 missing numbers. Let's do, for example, 1 here. My first term was 5, and my common difference was 11. That's all you have to fill in. The rest of the formula is the same. Let's do the same thing for example 2. I bet you could beat me to this. You could go ahead and write it out. So example 2 will be a sub n equals the first term, which is 12, plus n minus 1 times the common difference, which is negative 5. Now what this allows me, let's use this as an example here. For example 2 here, what if I wanted to figure out what the 11th term is? So let's do large one. Let's do the 101st term. Okay, so 101. So the 101st term, what I do is, to get for this one, I'm going to take 12 plus 1 less than that number, so that's 100, times negative 5. Now that's not so hard to do once you've got that information. Let's do that one more time here. Okay, so we're going to take 100 times my negative 5. So that's negative 500 plus 12. So negative 500 plus 12 will give me negative 488. All right, now let's go ahead and do it with these here. Let's have you take a look at these as examples. So for this one, you want to convert it from recursive to explicit and list the sequence. Okay, so for this one, notice it says that the first term is 10 and the common difference is 8. So these are the 2 numbers that I'm looking for when I do a sub n for the explicit. You know, the first term plus n minus 1 times the common difference. Well, the numbers I put in are 10 here, and I put in 8 for the common difference because I add 8 each time. And so let's go ahead and simplify this. 10 plus 8n minus 8. So a little bit simpler way to look at it is 10 minus 8 is going to give me a negative or positive 2 plus 8n. So there's my explicit formula simplified. And to list out the terms, it's going to be 10. Going to add 8, 18. Add another 8, you get 26. Add another 8, you get 34. And it goes from there. This is a sub 1, a sub 2, a sub 3, a sub 4. So, and etc. So if I wanted a sub 500, I just put it into this formula, 10 plus 499 times 8. All right, so let's write this one out. So this is going to be for my explicit formula, a sub n equals the first term plus n minus 1 times negative 2. And you could simplify that to get a simpler form. Okay, and then if you list out the numbers, you'd start at 21. You're going to add negative 2 each time, so that's 19. Add negative 2, you get 17, and then you can keep going. And lastly, let's do this one. A sub n equals, notice the pattern follows. The first term is 100. And you're going to have n minus 1 times the common difference, which is going to be here, is going to be 200. And so you're going to, if you want to, you can simplify it by multiplying 200 through. But I'm going to start with 100 for my term, first term, add 200, you get 300. Add the next term, 200, you get 500, and etc. So that's an arithmetic sequence where you start with the first number and add the same thing on each time to get to the next one. Now, what if we wanted to know what the sum of these were? What if I wanted to know what the sum of all these numbers were? Let's look at the notation for that, okay? That's called, instead of a sequence, that's called a series. So the next thing we'll talk about is arithmetic series. Sequence is just the list of numbers. The series is where you add up all the terms. So it's the sum of the terms of an arithmetic sequence. So let's do an example. My recursive formula, let's say I've got a recursive formula of, do example 1 here, of a sub n equals 12 is my first term, and then I take the previous term and I add to it. I'm going to add 4 on each time. So this is for n equals 1. This is for n greater than 1. That's a 4. All right, now this sequence would be just 12 to start with. Add 4, you get to 16. Add 4, you get to 20. Add 4, you get to 24. This is the first 4 terms of the sequence. Okay, the series instead would be, let's do one more. So let's do add 4 and you get 28. For a series, we're going to add those together. So we're going to have 12 plus 16 plus 20 plus 24 plus 28. That's a series of the first 5 terms of it. We want to add these terms together. Now here's a shortcut for you. A shortcut is to take these terms, and what you're going to do is add the first and the last. Then you go ahead and multiply by the number of terms there are. Notice I've got 1, 2, 3, 4, 5. Multiply by the number of terms. Sorry, it's so small. It's multiplied by the number of terms. I want to keep it one line for each. So add the first and the last, multiply by the number of terms, and then divide by 2. That's kind of a shortcut for if you want to add all those up. It's okay, this one, just 5 terms, you can add them up, but if you wanted to go and do it for a lot more terms, it would take more. All right, now this is the part that you want to make sure, oh, by the way, that's equal to 100 then. Okay, 12 plus 28 multiplied by 5 divided by 2. All right, now the last thing we're going to do is called summation notation. And summation notation is totally new. You're going to have to get used to it. It's something that takes a while to understand, but let's start off by understanding it using what's called the Greek letter sigma. The Greek letter sigma okay, that's what we're going to use to show that notation. It looks like this. We're going to use I equal to 1 up to n for the term a sub I. Okay, so this is to add the first n terms. Now that looks different, but this just tells you this is the subscripts on it. So this is saying if I've got a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, okay, for these different terms, if I want to add them, this is just saying start with subscript 1, go up to subscript n, in this case it would be 5, and add them together. That's what the sequence means. So as an example here, this would be, if I wanted to do up on that sequence, I would go ahead and have my I sub 1 equals 1 to 5 for that. Now, to put this in here, remember we have an explicit formula for each of these. To figure out where we are in the explicit formula, I'm going to write this explicit formula right below this one. Remember, that's just one line. A sub n equals the first term, 12, and then we're going to add to it n minus 1 times the common difference 4. Okay, that explicit formula goes right here. Because the explicit formula tells me what the a sub n is here, in this case a sub I. So what I get here is if I go with, if I put in here, for this formula, I'm going to put the sum, and I'm going to switch to n because I'm using n as my subscript, 1 to 5 of this formula, 12 plus n minus 1 times 4. All that means is put 1 into that. 1 minus 1 is 0 times 4 is 4. You get a 12. Add to it. Summation sigma means sum them together. Put in a 2. Count your way up to the 5. So 1 up to 5, put in a 2. 2 minus 1 is equal to 1. 1 times 4 is 4. 4 times 12 is 16. Count our way up. Go to 3. So we go up to 3, we go 3 minus 1 is equal to 2, 2 times 4 is 8, 8 plus 12 is 20. Put in 4, 4 minus 1 is 3, 3 times 4 is 12, 12 plus 12 is 24. And put in 5, 5 minus 1 is equal to 4, 4 times 4 is 16, 16 plus 12 is 28. Add all those up and you get the 100. So the summation notation for this, for our arithmetic series, which is adding up the sequence, is where you use this sigma, Greek letter sigma, count up from 1 up to n, however many you want to add up, the first 5 terms in this case, you could add up 6 or 7 or 100 terms, and you go ahead and put the numbers counting from 1 up to 5 into the explicit formula, and then add those together and you have your arithmetic series.